All right, again, just to be really, really clear, so you don't lose points on homework and not know why, when you are screenshotting your score from AP Classroom, I should see your name in the top right corner, okay? And you want the latest assignment at the top so that it's nice and easy to find. If you sort by start date, so if you click on start date, it will sort it. First time you tap it, it goes the other way around, brings the last one or the first one up. If you tap it again, it goes that one, or you do your little drop down menu and you can adjust it. But it will always pull the last one all the way to the top. So on Mondays, 2-1 should be all the way at the top. All right, so the good news about today is that most of this is review. We did arithmetic and geometric sequences. This is also a regular like pre-calc. This is a topic that's actually in your book, but it's not until chapter 8. So we just pulled it forward. Okay, obviously notation goes a little bit different with when you get into the AP stuff, but for the most part, there's a good overlap between what we've learned before and this. So a sequence is an ordered list of terms. It can be infinite or finite. So the example that's here is 1, 2, 4, 8, ... That means continue on forever in that pattern, and that means that that is infinite. If it just said 1, 2, 4, now we're talking finite. So obviously finite means it ends, infinite means it doesn't. This is just some vocab, but each listed item is called a term. So we're going to say, like the 7th term, the 6th term, like that. And if you were to plot these on a graph, it would be something similar to what we do with our stat plot. Okay, it would have some sort of correlation because these are going to be arithmetic or geometric. But if it was at like the first term would be 1, the second term would be 2, the third term would be 4, the fourth term would be 8. And it would literally be separated out like that in points. They are not connected lines. There are 2 special types of sequences we're going to talk about today. The first is arithmetic and the second is geometric. A sequence is arithmetic when the differences between consecutive terms are the same or there is a constant rate of change. What does that sound like? What kind of functions have a constant rate of change? Linear. Linear functions have a constant rate of change, right? So like actually in the next section, it is saying how that those are basically the same things. Arithmetic and linear will overlap, okay? But we are talking about sequences when we say arithmetic. So if I'm listing the terms in arithmetic sequence, you are either increasing or decreasing by the same amount. So if I start with 2, I can say if I add 3, I get 5. If I add 3, I get 8. If I add 3, I get 11. This would be an arithmetic sequence. But I could also subtract 3. I could say 2, and then I could say 2 minus 3 is -1. -1 minus 3 is -4. -4 minus 3 is -7. That would also be an arithmetic sequence. You are increasing or decreasing by the same term. These little terms, this would be A1, A2, A3, A4. That's what the little subscript numbers are. Any term in that sequence can be referred to as A sub n. So AN is the nth term in it, and it might say like find the nth term, and it will give you n is 7. That means find A sub 7. The common difference is what we call the difference between each of these. So in that first example, the common difference is +3. In this second example, your common difference is -3. So that's how we know if we're increasing or decreasing. It will actually have that sign. And the variable for the common difference is D. So it will oftentimes just say like, what is D? And D would be either +3 or -3. Example 1 says determine whether or not the sequence is arithmetic, and if it is, find the common difference. So what we want to do here is basically see if I can add the same thing, or if I want to go right to left, I would do 4.3 minus 3.7, and it's 0.6. I would do 4.9 minus 4.3, it is also 0.6. 5.5 minus 4.9, 0.6, and 6.1 minus 5.5, 0.6. So because they all have the same difference, this is arithmetic. And the common difference is 0.6. All right, find the nth term. So if it asks for the equation for the nth term, or just asks to find the nth term, the way we find it is this, guy. So this is the first of two formulas you're going to need to know from today, okay? A sub n equals A1 plus D times n minus 1. So A1 is your initial term, D is the common difference, n will stay as n in my initial equation, and then if I wanted to find something like the seventh term, I would plug 7 in for n. You will also see it distributed out, so it could say A1 plus Dn minus D, and you would actually then combine the A1 and the D. So this is your initial equation. But then once you actually fill in those terms, sometimes they will distribute and simplify. All right, so example 2 says write a rule or an equation for an for the arithmetic sequence. So number 1, or A, sorry, gives you A1 and D. So an equals A1 plus D times n minus 1. An equals 100 plus a negative, which means minus 8 n minus 1. And that is a totally acceptable answer. If it is open-ended, I'd take it. If it is multiple choice, you'd have to know that that can also be distributed. So it can also be distributed here. I'd get 100 minus 8n plus 8, or 108 minus 8n. You will also see questions that say, you select all of the choices that can get you that nth term. And so these might both be in your answer choices, and you'd have to select both. So again, if it's open-ended, I'll take either one. If it was multiple choice, you would need to know those both mean the same thing. All right, go to B. This time I've got a series of numbers, right? I don't have D yet. How do I find D? Find the difference. So I could do 3 halves minus 4. 3 halves minus 8 halves, which is negative 5 halves. That's D. So an equals 4 minus 5 halves times n minus 1. So your common difference could be a whole number, could be positive, could be negative, could be a decimal, could be a fraction. There's no restriction on it. Question so far? All right, example 3 says 2 terms of the arithmetic sequence are given. Find the missing term. So there's a couple different ways to do this. One is like manually try to find the difference. The second is set up an equation in which you can skip terms, okay? So we did this with briefly yesterday with the geometric one, but if you were to, let's say we're finding our equation, an equals A1 plus D times n minus 1. Now let's say I was going to the fourth term in this case. My fourth term would be what n? 4. So A4 would equal A1 plus D times 3, or A4 would equal A1 plus 3 times D. Now just so that we can observe a pattern, let's say I was looking for A5. It would have been A5 equals A1 plus D times 5 minus 1. A5 would equal A1 plus D times 4. A5 would equal A1 plus 4 times D. So there is a pattern. If I kept continuing to do it, what do you notice about the right side and the left side, or specifically the n on that side? If I take my A1 term, the sub 1, so 1 plus the 3 on the front gives me my 4. So these two have to add up to that one. So these two would add up to that one. which means you could literally skip around terms. You don't have to always use A1, and you don't always have to go just one term. Does that make sense? You can skip around. So if I'm doing this one, I'm going A1 and A4. So A4 equals A1 plus 3D. A4 is 17. A1 is 8. And then I can subtract 8. I get 9 equals 3 times D. Divide by 3. And D equals 3. Now, it said find the missing term. So I can either go back to the beginning and say AN equals A1, which is 8, plus D, which is 3, times N minus 1, and I can plug 8 in there. Or I can use the A4 term, and I can say AN equals 17 plus, what would be the difference from 4 to 8? 4. I could say 4 times D, and I could use D as 3. So in both these scenarios, our N is 8, so this would be 8 plus 3 times 7. 8 plus 21 is 29, and 17 plus 12 is also 29. So you don't have to use your initial term once you establish what D is. You can do A of whichever term plus the number that's the difference between N and the, so like if I did AN equals A of any number here, any other term here, plus this would be N minus that number times D. So the way an AP will kind of throw all that at you is it will say find the equation and then find all the other ways that equation can be written. So you'll see stuff that skips terms like that. You're just going to be really careful. Good? Yes? All right, now we switch to the second type, which is geometric. So geometric sequences are sequences in which the ratio of the consecutive numbers are the same, or I am multiplying by the same thing each time. All right, so if my sequence is A1, A2, A3, and so on, then A2 divided by A1, A3 divided by A2, and A4 divided by A3 will produce the same number. This time it's called a common ratio, and our variable is R. R cannot be 0, otherwise there would be no term. They would all be 0. And you can either like see what you can multiply by, or if you don't see it right away, then you can work backwards. So let's say I have 3, and then I multiply by 2, it's 6, and then I multiply by 2, it's 12, and then I multiply by 2, it's 24. And you can just see that it's doubling every time. R is 2. But if you don't see it right away, then make sure you put the second term over the first, the third over the second, and the fourth over the third. Don't reverse it. So if you can see the multiple, then just use it. But if you need to find it, make sure you do the one on the right over the one on the left to find the ratio. And again, that's R. All right, example 4, determine whether or not the sequence is geometric. So if I look at A, from 3 to 4, from 3 to 12, I'd be multiplying by 4. From 12 to 48, 4, and then 48 times 4, because we don't know that in our head. I mean, maybe you do, but I don't. It's 182, which is also 4. So my answer here is yes. And if it asked for it, R was 4. It didn't ask for it, but if it had, R is 4. All right, B. Now we get into fractions, and I would say it's less obvious, but if I did 1/2 over 1, I'd get 1/2 times 1, which is 1/2. If I did 1/3 over 1/2, I'd get 1/3 times 2, which is 2/3. If the first two don't work, it's a no. You don't have to even keep going. Maybe if it was a test, I'd check it just to be sure that you didn't make a mistake. But as soon as you get one, that's different. It's a no. And just because two are doesn't mean the third is, so you need to make sure you check. Still good? All right, write the first 5 terms of this geometric sequence. So I give you A1 is 1, and then R is 1/2. So A1 would be 1, and then 1 times a half, a half. A half times a half, a fourth times a half, an eighth, and an eighth times a half, 1/16. And those are the first 5 terms of the geometric sequence. Question so far? All right, finding the nth term. So this is your second equation from the lesson. And that is the nth term of a geometric sequence has the form of A sub n equals A1 times R to the n minus 1. So now we're multiplying something that's being raised to the power. The n minus 1 is in the exponent. Example 6, find the formula for the nth term of the geometric sequence. Find the indicated term of the geometric sequence. So first, I know I'm going to eventually find the 7th term. That means my n is going to be 7 when I find that. And the sequence I'm given is 3, 36, and 432. It tells you it's geometric, so you just figure out the easiest pair, right? 36 divided by 3 would be what? 12. So R is 12. And I get A-N equals A1, which is 3, times R, which is 12, to the n minus 1. Now be careful because the n minus 1 is only on the 12. You don't multiply 3 times 12 and then raise it to the power. You're raising it to the power and then multiplying. So if I want to find the 7th term, it would be 3 times 12 to the 7 minus 1, or 3 times 12 to the 6th power. Not something I expect you to do without a calculator. 12 to the 6th is 2985984 times 3 is 8,957,952. All right, 7 says, find the indicated term of the geometric sequence. So it gives you A1 and it gives you A4, and it's asking you to jump to the 10th term. So this is kind of similar to the arithmetic one where we skip terms, right? So we have to figure out the pattern here. So if I wanted to find A4, I would have to do A1 times R to the n minus 1, and that n is 4, which means it'd be A4 equals A1 R to the 3rd. If I kept doing this, you would see the same pattern occur, which is that now the base, which we used the first time with arithmetic, but this time we're adding the exponent. So the base plus the exponent has to give you the term you're finding. So in arithmetic, it was the multiple, the thing on the front, the coefficient on the front of the n. No, of the d, sorry. The coefficient of the front on d. And now we're talking about the exponent on the r. So now if I plug in A4 is 1/2. A1 is -4. R is being raised to the 3rd power. I would divide both sides by -1/4 or divide by -4 or multiply by -1/4. And I get R to the 3rd equals -1/8. And then I'd cube root both sides. And what's the cube root of -1/8? -1/2. Good. Cube root the top, which would be 1. Cube root the bottom, which would be 2. And it's negative because it's an odd root. So now I found R. You with me so far? Now I have two choices. I can either go from A1 to A10, or I can go from A4 to A10. So I'll show you what that looks like, because again, you'll have to pick this out of like a multiple choice. If I went from A1, it'd be A1 times R to what power? The 9. If I went from A4, it would be R to what power? 6, right? These have to add up to this one. So I'm just going to use the bottom one, but you could have used either. A10 would equal A to the 4th, which is 1/2, times R, which is -1/2, to the 6th. So 2 times 2 times 2 times 2 times 2 times 2 is what? 64, and it's positive, and this would be 1/128. If it says to round it, go away, then it would be 0.0078, so 0.008. I assume something like this would be on the non-calculator part, because you can do that without it, and you would leave it exact. All right, this one says, find the indicated term of the geometric sequence. Now we're going from 2 to 5, so we can't even use A1. So if I have the 5th and the 2nd, which one goes on the left? If I'm setting up my equation. Bigger. Bigger go, otherwise your second. If you do the smaller, here, let's talk about it. If I did this, what would my exponent have to be? Negative. We don't want to do that, right? You can do it that way, but you don't want to do that if you can avoid it. So if I put it the other way, A5, A2, what's the exponent on R? 3. So A5 is 2/3, A2 is -18, R to the 3rd. Divide by -18 or multiply by -1/18. 2 goes into 18 9 times, and I get R to the 3rd equals -1/27. And I cube root, and the cube root of -1/27 is -1/3. Now I can set up my whole equation using 2 and 6. Wait, A2. R to the 4th, or if I have the term before the one I want, what could I do? Just multiply it. Still with me? Yeah? Last one says, find an equation that gives the nth term of each sequence. Instead of the initial value, use the k term of the sequence in your equation. So first of all, we got to figure out, it doesn't say if it's geometric or arithmetic, right? So I have to figure that out first. If I look at A, what's happening here? You're subtracting by 30, which makes this what? Good. And D is -30. So now instead of saying the initial value, it wants K to be 2. So we're saying A1 is not A1, it's A2, minus 30 times N minus, if I usually start with 1, and this is a 1, if I change it to start with 2, this becomes a 2. So this is still, actually, this is still A1. Ah, give me the eraser. Actually. So what we had started with is this, right? We said A2 would be minus 30 times N minus 2. This is going to match whatever the K value is. If I was on the third term, it would be 3. If I was on the fourth term, it would be 4, okay? And then we're actually going to plug in what our A2 is. So we're saying that this is not really A1, that is A2. So 50 minus 30 times n minus 2 would equal a, and that's how you'll write it. You'll actually use the value. So all that means is that your first term is really not A1, it's a of whatever k is. So the k not only is what that first term is what you're grabbing, that k is what you're going to subtract instead of 1. And sometimes they give you k as 1, which is, it's just normal. But if not, it's the k value that's there. All right, B. B is 2, 4, 8, 16. Are we adding the same thing each time? Nope, we are multiplying, which makes this geometric. What is R? R is 2 because I'm doubling it every time. So it's telling me to use k as 3 this time. So my first term is 3. So an we're saying would be a3 times r to what exponent? If this is normally n minus 1 and k is, excuse myself. Okay, if you are doing a1 times r to the n minus 1, right? The number here is what you're subtracting from there to get your initial term. Yes? So if it was a0, it would be back 1, okay? So those numbers are going to match up, which means if my initial term is a3, then I'm going to do n minus 3. You're going to match it up, okay? So if I was finding the 7th term, it would be a7 times r to the n minus 7. Whatever it's given, okay, is the first. But I'm not leaving it like that. I'm plugging in a3. I'm saying that this is not just a1, that is actually a3. So an would equal 2 times r to the n minus 3. So when it's arithmetic, I make whatever I'm subtracting from n, the k. And when it's geometric, I'm making whatever I'm subtracting from the n in the numerator, in the exponent, k. Does that make sense? Did a bang up job with that. Yeah, questions?